Hello there to all of you who are a part of our Mastering the Basic Math Facts professional development. I want to say a thank you to Shelley Alford for kicking us off this year and getting us started with the addition and subtraction part of the Mastering the Basic Math Facts. And now it's hard to believe we're already here, but we are ready to transition over to multiplication and division. So for some of you, this will be probably what you've been working on with your kids already this year. For others of you, you may not spend a whole lot of time with multiplication and division depending on the grade level you teach. However, I do have to believe that in the course of our careers, we generally end up in a variety of roles, and we end up working with kids from a variety of backgrounds. So hopefully these will be some tools that will help you whether it's this year or into the future. Maybe it's with your own personal kids, or maybe it's with the kids that you teach. So you'll see here on our screen that we have the page pulled up from our Edmodo group. Thank you to those of you who have been able to already contribute your thoughts here to our opening question for this week. If you haven't had a chance to do that, no worries, just get it in there so that we can see how each other have approached our opening question. And that question, as you can see there on the screen, was simply, how did you learn your multiplication facts? And then to think about a student, perhaps a student that you were a student alongside when you were in elementary school, or perhaps it's a student in one of the classes that you've taught, or maybe somebody this year, but a student who has struggled with their multiplication facts. And maybe some of us in this group struggled to learn multiplication facts, and maybe that's why we're in the group. You'll see, or I see in the responses, that most of us have said that we use some form of what we might call traditional practices, and there's certainly nothing wrong with traditional practices. But we also have been, all of us have been part of this profession long enough to know that traditional practices work for some kids and they don't work for others. So we are certainly looking to add to our toolbox here for our kids. So we see things like around the world. I think the students that I taught me around the world, but we see things like flashcards, and my parents helped me, and we just worked on it, and some of us are just honest enough to say, I don't really remember how I learned them, but I've learned them. So repeated practice seems to come up in this, right? And so making sure that we have repeated practice is a huge part of learning our multiplication facts, and making sure that we're paying attention to how kids learn and that they're comfortable in that process. So lots of good feedback here, lots of good conversation. So as you think about this, PD, we want to think both about how we learned our facts and also how other people learned the facts. We know that we're kind of a skewed data sample. We're all teachers, and probably more than likely we did okay with these things, but perhaps many of our peers did not. I share this. I was actually talking on Facebook with one of my third grade teachers, and she shared with me just an insight that I thought was pretty relevant to what we're talking about here today. And we were chatting back and forth, and she's been retired now for probably 8 or 10 years, just because I'm old. But she was sharing that she sees a lot of things that people put on Facebook or out in social media as if we haven't been doing some of these practices in the past, and that these are brand new ideas. And she was sharing that, when she was teaching, even when she was my teacher, she did a lot of these things. And her thought was that as students, a lot of times we don't remember how we were taught. We just remember what we were taught. And so that's really kind of caused me to think a fair amount about that. Maybe as teachers, sometimes we just remember that we learned it, and sometimes we don't remember exactly how we learned it, especially these things that we learned early on. So as we go through this, please know that we're not saying these are the only strategies or that these are the best strategies. These do tend to be research-based strategies. They tend to be things that work more often than not. But we know ultimately in math that we've got to find pathways for our kids to learn that match how they're going to learn it. Otherwise, we're just going to move on, and kids won't know it. So hopefully this will be a good chance for us to all pull together our resources and our common knowledge. So this is the picture of the book, and we may have shared this earlier, but the Mastering the Basic Math Facts book. We do have some copies of both the addition and subtraction book and the multiplication and division book, and we certainly would like to share those with you. And so as we get to the end of this PD, we will be asking you which one of these is more suited to the area you currently teach or that you anticipate teaching. And if neither one is beneficial to you, then that's perfectly fine too. But we do want to make sure that you have access to the resources as we move on. So let's talk about this, getting into multiplication facts. So when you think about the basic facts, you might think about facts from 0 to 5, or you might think about 0 to 10. You might think 0 to 12. Some folks will go even into the 13, 14. Very rarely do we go much higher than that and consider it a basic fact. But what I find in talking with teachers is sometimes we have different definitions of what the basic facts are. And so in terms of this text that we're using, we're going to define the basic facts as the facts from 0 through 10. And if you want to add in strategies for 11s and 12s because those help kids as well, that's fine. If 0 to 10 means 5 times 22 to you, then that's probably not what we're going to talk about in this group. We're going to stick within facts of 0 to 10, but we can certainly use those strategies for larger values, especially when we're talking about things like doubles and 10 times the values, because we know those are well within our standards as well. We asked you early on in this professional development in the Edmodo group about what your definition of mastery is. And we want to distinguish between memorization and automaticity. So we're going to look at a little bit of that today. I know that'll be a little redundant from our very opening session, but I just think it's really important that we kind of keep focused on, we're not necessarily talking about memorization, and we'll talk more about why that is as we move on. When we think about the whys, it's always important to think about why we do things, right? So why do we remember our math facts? And there's 3 real keys here, because every now and then we'll run into a parent or a student who's going to say, I don't need to know these. Why are you making me memorize these? Or why do I have to remember these? Why do I have to keep practicing them? Well, there's these 3 main reasons, right? The first being the ability to generalize. If I really understand how the multiplication system works, then I can generalize really basic things and expand them, right? So just quick examples, right? If I understand how that times 2 is a doubling, and that I've been doubling things since kindergarten, that if I know that, then I can do times 3, because times 3 is just doubling and 1 more, right? So if I understand that 2 times 8 is 16, so I can remember my doubles because I can picture 8 and 8, and I can see 16, well then I know all my 3's, because it would just be 16 and 1 more group of 8. So 16 and 8, well, that's going to be 24. So if I know my facts, I can generalize them to other situations. That also applies to bigger numbers, right? So if I know that 2 times 8 is 16, then I know something about 20 times 8. And I know something about 80 times 20 or 800 times 200. But I can't really generalize if I don't know those basic facts. A second reason is working memory. A number of our students, a number of kids that we work with, especially when we're first learning something, but just in general, a lot of our kids have struggle with working memory. And we know that when we're attacking something new, when we're reading a problem, when we're thinking about something that we don't automatically know, that the working memory gets taxed very quickly. It fills up, and we can only hold those 5 to 7 bits of information there in that working memory. So if I'm thinking about how do I solve, or what is the fact here, what is 5 times 7, if I'm spending a lot of working memory thinking about the answer to that, it's going to be very hard for me to hold on to what was the question asking. So sometimes we probably fault kids, or we maybe even laugh a little bit that kids will just take 2 numbers in a problem and they'll put them together and they'll add them or they'll multiply them and they'll do whatever. Sometimes that's a simple result of a struggle with working memory, or that working memory is taxed. So the more automatic we get with our facts, the more easily we can grab that part, that memory, pull it up when we need it, and I can spend my real mental stamina thinking about what the kids are, or what the question is actually asking me to do. And then finally, estimation and reasonableness. So we know that once we understand our basic facts, then we're able to, like we were saying in the first part, we can generalize those facts out. But we also understand when something makes sense and when something doesn't make sense. Oftentimes we begin by asking kids, is this a reasonable answer? And sometimes it's easier to actually do the math than it is to determine if it's reasonable or not. Because reasonableness takes, in my thinking, it takes two thought processes. Both what would I expect to get here, how would I round it, how would I do all those things, and then to do that math and say, is my answer reasonable? So the more automatic I am with my facts, the easier these three things are going to be for me. There are a variety of resources. So when you decide on a book, you will get a login code through Heinemann, and that login code will give you access to all the printables within the book. So anything that we'll share as we go through this, you will see that you have access to download those from their website, but you do need the access code in order to do that. And as much as I would just like to send you that access code, that would be probably unfair to them, and it would be breaking copyright. So we will make sure that if you when you get the book, then you'll be able to access all those printed resources. We are able to select a few of those things and share them through the professional development, including some things like the pre-assessment. And so we'll talk about reality versus the ideal, but if we're going to do something with math facts with a group of kids, if I have 25, 35 kids, however many there are, that I'm going to be teaching, I have to be honest and say, those 25 kids are not all in the same place. They don't all need the same math fact practice. They might all need to work on some of the same strategies, and it's certainly okay to give some strategy practice to the whole group, but we want to make sure that when we're asking kids to practice their facts, that they're practicing the facts that they need to be practicing. If I already know my 2s, 3s, and 4s with the speed and accuracy, fluency, all those pieces that I need, then I probably don't need to be doing 2s, 3s, and 4s. And there are some pretty easy ways to manage that as a teacher, and we'll look at some of those as we get further into this professional development. Many of you probably have some great strategies for that, but we'll chat more about that later. But we do need to establish where are these kids, because if they have been doing, if I'm a 5th grade teacher, it's pretty likely they've been doing multiplication at least to some degree in 3rd grade, 4th grade, and now they're with me in 5th grade. And if I start them all back at ×2, I'm probably wasting some kids' time. And then if I move them all forward at the same pace and set dates like, well, by October you need to have your 2s, 3s, and 4s, and by November your 5s, 6s, and 7s, well, if they're not there, then we're just saying, okay, we're moving on regardless. So we want to make sure that fact practice is part of our daily routine, or at least our weekly routine, that we're giving time to practice, but that we're also honoring that different kids are in different places. And so this is a great place that we can compact some of the pieces that we're teaching too. If I've got 7 kids who are done with their math fact practice, they could be doing something totally different during that time. Not necessarily more work, but truly different work. So there is a table and some resources within our book that get us into the aspect of what does the student already know. We can think about how bored we would be if somebody was just giving us our ×2 tables. Although sometimes it's fun to see how fast we can do them, it's probably not the best use of our time. Deciding which facts kids are automatic with already, and then also determining, do they have understanding of those facts as well. So I may appear to be automatic, I may have just memorized some things, I may really not know what 2 × 8 looks like. And if I don't know what it looks like later in math, that's going to show up as a deficit, although right now it may look like a strength. So as we look at our schedule here over the next few weeks together, this schedule will take us up to our break in December. So this is the week of November 2nd, so we're doing our overview, and then we're going to jump in You can see the schedule there with the 9th, the 16th, and onward there. We are not going to post any work during Thanksgiving. You're certainly welcome to catch up during that week. You're also welcome to not log in during that week. I don't know. I may or may not be online that week. So I give you the same privilege, I guess. Is that the right word? I don't know. But we'll look at wrapping all this up by December 14th. If we have to push back something a little bit, then we'll do that as well. You'll notice that our target has always been December 19th to have everything done, caught up, knocked out. However, a couple of you have said, can I have over the holiday break? If that's what you need, that's fine with us. We don't have to turn in our sign-in sheets until January. So if you would like to have the holiday break, please just let me know, especially, and I'll hold off on checking off what work is done until then. However, if you are done, then you're done, right? So you may want to have it done by December 19th so that you're not worried about this over break. All right, so let's talk a little bit. I'm going to switch screens here on us just for a second. Let's talk about the progression of our facts. So I think I've already zoomed this in just about where I want it there. Okay. So our book goes in a certain order, and you would have seen that, or you just saw that on the on our timeline piece. See if I stretch this out, if it's a little bit clearer for you guys to be able to see out there. So we're going to treat, or this text treats facts in two groups: our foundational facts, and then the facts that build upon that foundation. Just like any foundation, if these 5 facts are not strong, it's going to be really difficult to master the other 5 or 6 facts, right? So you can see that we're going to look at our 2s, our 10s, our 5s, our 1s, and our 0s. It's easy to say, oh, kids know anything times 0 is 0. But the hard thing is, as it points out here, and we'll get into that when we spend time with it, it's harder to conceptualize nothing. It's hard for kids to picture that if we're talking about 0 times 5, that what we're talking about is no groups of 5. You say, okay, draw no groups of 5 for me. Well, it's a little trickier than drawing 2 groups of 5, right? So we hold off on 0, although a lot of people might say, do 0 first. Well, it doesn't actually work that way cognitively as well. So we're going to look at these. You can read those descriptions there on your screen. I think these are probably the first 5 that most of us would have started with, although we have also seen, and I've probably been guilty of taking kids through 0, 1, 2, 3, 4, 5 and building up like that. But when we start thinking about how facts play off of one another, it makes a little more sense to take them out of order. So these first 5 facts then get built on, once we had that foundation in place with our kids, then we get to build on those and look at our 3s, our 4s, our 6s, 9s, 8s, and 7s. I probably don't need to ask you guys why 7 would be last. You probably live that dream all the time. 7s are tricky for kids. 6s are, you can figure out our times 6 because that's doubles and triples. We can do it times 5 and 1 more. We can do all those things. Our 9s we can think of as 10 groups of 10 less 1. Our 8s we can think of as doubles, right? But 7s, it's a little harder, right? It's not as convenient as working with our doubles or working with triples. So we hold off on 7s until the end. And we'll look at it on the multiplication chart later as well. But we know that the beauty of weighting is the number of new facts at that point is pretty small, because obviously you've already done 0 times 7 and 1 times 7 and 2 times 7 and 3 times. So we've already hit all the times 7s. It's just now thinking of it starting with the times 7. We'll certainly look at the commutative property and how we can use that. But I don't know if you've had this experience, but most of the kids I work with, that's a struggle, is to realize that 3 times 7, they may understand it has the same value as 7 times 3. But when I see 3 times 7, or if I see 7 times 3, sometimes as a student, I don't automatically switch them around and be able to remember, oh, that's 21. Especially our kids who are struggling. So we'll talk about those pieces and ways to work through those, and sometimes just ways to practice our way through. So let me put that to the side. Mentioned a little bit about the pace of our professional development. We will be using students, or we're going to ask you to use students at times, but I'm going to totally put on the caveat of if appropriate. If you're teaching kindergarten kids, you do not need to subject them to multiplication and division. Please know that we understand the reality of kids out there. We also know that we are in the middle of the year at this point. If we were doing this in the summer or we were doing this early in the year, it might make great sense to pre-assess our kids, but it may not make much sense right now to go back and pre-assess your kids because you probably already know which facts they know, which facts they don't. So make this make sense for you. If addition and subtraction is where your kids are, put yourself through these paces. See if you can find a child. I'm pretty sure there's somebody in every school who could use a little extra multiplication help. But if you really can't get to a kid, then just go through these paces on your own, and we totally will understand that. And we also ask in the pacing of this PD, please share your experience. What kind of things did you do in the past? We've all done things in the past that we'd say, oh my goodness, I will never do it that way again. And we've done things in the past where we say, this works great. And it really actually connects with a lot of kids. So share those pieces, both the things that worked and the things that don't work. That's the way we all learn from one another. That goes for the things that you're currently using and also some things that you're looking towards. A lot of times there's things like this or like other technology-based resources that you may be just starting to explore and you're thinking, maybe I want to share that. Please do, because this is a great group. It's a small group, but it's a group that can benefit from one another's expertise. We've already talked about the basic math facts. A quick flashback to that opening session way back in September or October. That when we're talking about mastery, we're talking about two things, automaticity and understanding. So automaticity, not to be confused with memorization. Memorization is actually pretty easily lost. We've all memorized certain things for a test, and then we forget about them. You may have been sitting somewhere like in church, and you hear something, you say, I'm going to memorize that. I'm going to memorize that verse, or I'm going to memorize what the pastor said. And you memorize, and you think about it, and you say it 100 times to yourself, but it never really enters long-term memory. And so it's there, but it gets filtered out, or it's not. Maybe it is in long-term memory, but it's not connected to anything. So it's incredibly hard to go back and retrieve. So the old saying of we've probably all forgotten more than we remember is most likely true, because that's the way our brains have to work sometimes. A lot of times when we come back across something, we remember that we knew that at one point, but we may not remember how we learned it. So when we are talking about mastery, and we're talking about mastering the basic math facts, it's not a fast process, and it's not as speedy as sometimes our standards would like, but it is something that if we're really going to focus on long-term success for our kids, we want to look at automaticity, that ability to recall the fact, but we're recalling it because it's attached to a lot of other information, and it's not simply remembering, but it's truly understanding what does that fact look like, what's a physical representation of it, could I manipulate it, how can I use that in other situations. So that's our big definition of mastery, and that one can't be overlooked in this PD because we're not talking about simple short-term memorized facts. Those kind of things are the ones where we see a kid in 3rd grade and we say, oh, he memorized his multiplication facts. And then he hits 4th grade and the 4th grade teacher says, he doesn't know his facts. And then so we do it again, they memorize them again, and in 5th grade, oh, he knows some of them. And by 6th grade, they're looking at us and saying, what do you guys do with our kids in elementary school? They don't know their multiplication facts. So we need to make sure we're going deep enough that that we're really shooting for mastery. So we have talked about this, so I am not going to dwell on this, but I did want to put it in the slide so that you were able to see it more in terms. So let's play a little game. We've got 2 sentences here, and I'd like you to think about this first sentence and thinking about this in terms of understanding. So which of these is easier to remember? Sat, chair, read, girl, a in, little, the, or. Got it? Remember it, right? Or is it easier to remember a little girl sat in the red chair? I think that's pretty easy, right? We can probably all recite that back if we read it to ourselves a few times. A little girl sat in the red chair. Think about what you're doing mentally with that sentence. For myself, I'm picturing my daughter sitting in a chair that happens to be red, and so I can remember that a little girl sat in the red chair. However, if you ask me to remember sat, chair, red, girl, a, and little, the, it's all jumbled, right? There's nothing, it doesn't connect to anything. If you really made me sit and say it enough times, and if you maybe even just gave me pictures of each of those words, I could probably give it back to you later, right? I could say sat, chair, red, girl, a, and little, the, and I could say it and say it and say it and say it and say it until it looked like I really understood it. But I probably would never have the picture of my daughter sitting in a little red chair, and I wouldn't be able to do anything with it if I just remembered it as sat, chair, red, girl, a, and little, the. I'm sure you've already made the connection to multiplication, right? Asking kids to memorize numbers on a page, regardless of your intellectual level, can be incredibly discouraging for kids, right? And if I struggle with this day after day after day, year after year, and my parents are on me, my teacher's on me, I pretty quickly start to feel like I'm not good at math. And yet, if we looked at those 2 sentences, we would never say to a child, sat, chair, red, girl, a, in, little, the, and if you don't understand that, then you're not good at this. We would say, maybe we need to put it in perspective. Maybe we need to shift things around so it makes sense to you. And that's what we're asking ourselves to do, is how can we make the math, how can we make multiplication make sense to our kids? When we really look at how kids make sense of equations, I'm going to flip back in our book here. We can see that different kids attack different questions, different problems in very different ways. And when we give kids a variety of ways to think about the math, it becomes so much easier for us and it becomes so much easier for them. So we're going to talk about shelves and books later, but we're also going to look at that in terms of a birthday party. So for sake of time, I'm going to jump over this one, but if you do get the multiplication book, you may want to go back and check out the variety of examples there in terms of books and shelves and how many books are on a shelf and how we phrase those different kind of questions. So let's get into how we can help our kids, and then we will progress from there. So when we think about helping our kids, we know that kids need to understand their operation. They need to understand addition and subtraction and multiplication and division. They need to understand what those things are, what's happening when I add numbers. We know that these things need to be based in examples that are kid-friendly, that live in the kids' world, things that kids are interested in. So they also need to be tangible. We need to give kids plenty of experience with the concreteness of math, and the discussion piece. And I don't think that changes no matter how young or old we are. In fact, in just talking with some high school kids yesterday about the math and asking them what made good math class different from struggling math class, the overarching thing was the chance to talk about it, talking about it with a teacher, with another student. The discussion piece is huge. And then connecting it with literature, right? Kids like literature. We all like to be read to. So connecting with literature is a keen way to help our kids. Helping kids understand that there is no one way to think about something even as simple as 4 times 3. Some people are going to count each object. Some people are just going to remember it. But they remember certain patterns, right? And that there are certain things that are more efficient than others. So you can count every object in a problem in 4 times 3, and you'll get 12. But it's quicker if you think about it in terms of doubles, doubles, right? It might be quicker yet if you think about it in terms of the 3 groups of 3 and then another group of 3. There's not necessarily just one way to get there. Ultimately, we want to have enough experience that we can make the efficient move of saying, well, I just know that 3 times 4 is 12, but I know that because I know that 3 times 3 is 9 and 3 more makes 12. And that's where we get into understanding the math to where the distributive property makes sense, right? And where some of the things we do in algebra start to make sense to us. And once kids know that, or once adults, when we all know that, we know that strategies work regardless of when memory isn't always our friend. So we'll look at all kinds of strategies and strategic thinking, doubling, halving, switching numbers around, properties, but only in terms of how they help us remember our facts. What works in terms of helping kids is brief, repeated practice, right? So having that 5 to 10 minutes built in a schedule, it can certainly be a station, it can be the first thing in the morning, the last thing in the afternoon, right after lunch, in the lunch line, whatever it is, matched to what my needs are, but short and repeated throughout the school year. What tends to not work? Speed and elimination drills. Right? So the mad minutes and things like that, the worksheets can work fine, but they need to be matched to the student's needs. Speed needs to probably be underemphasized, although eventually we want to be efficient with them. And we certainly don't want to do things that eliminate kids and leave kids behind, and while the rest of the class is going to move on to their 7 tables, even though you're not done with your 2s yet. So we need to think about those things as we go through. Our text goes into thinking about the big ideas, right? And the big ideas in mathematics. Shelley spent a lot of time with these, I believe, in the addition and subtraction part, so I won't dwell on these a huge amount. But remembering that our number system is about patterns, that we use a base 10 system for the very reason that it's a pretty easy patterning system to follow. The doubles are very efficient. The 5 facts and 10 facts are pretty easy and pretty efficient to remember. And all of that serves the purpose of being predictable. That I know what's coming next because it always works this way. If I take 2 even values and I add them together, I always get an even value. And those same kind of rules when I'm multiplying, right? That 2 times anything is going to be even. Well, why is that? Well, because even if I have that odd value, I'm giving it another pair, right? So now, even if I have 3 and 3, those 2 odd values come together when I double. So kids understanding that and being able to predict what's going to happen makes it much more comfortable. One of the big ideas in multiplication and in division, when we're adding, we tend to be adding individual objects, but when we start multiplying and dividing, those numbers might represent the individual thing, or they might represent the group. So I could have 7, or I could have 7 groups, or 7 in a group, and all those things have a different representation. We build on the idea of the commutative property, that the order of the numbers doesn't matter. It might determine something in terms of length and width versus width and length, but my solution is going to be the same. So we look at that. We make sure that we dive into the ideas about addition and multiplication, and that those two go hand in hand. So if for some reason I'm struggling with the multiplication, I can always go back to what I know about addition to help me solve it, as long as it's helping me remember or get me to a solution, and that I continue to practice so that my multiplication skills get better. That multiplication and division are opposites. So if I'm looking at number bonds with that 6 times 3 is 18, then understand that's talking about 6 groups of 3 or 3 groups of 6, and that together those would make 18. But the opposite is also true. The inverse is true, right? That how many groups of 3 are in 18? Well, there's 6. And how many groups of 6 are there in 18? Well, that'd be 3. And we can picture that and how that works. The biggie and the way we know that when kids really own it, when it's theirs, is they understand that numbers are flexible and that you can pull apart values, and that you can understand that 4 times 6, that we could break that 6 into 2 3s, and I could do 4 3s and 4 3s, right? That the 6 could be 1 and 5, and I could do 4 times 1 and 4 times 5. And no matter what I do, I'm just decomposing that to a more convenient value or to a more convenient number for me. You, as a teacher, you may say, I'd never do that. But if a kid understands that, then they are going to understand when you get into algebra why I'm allowed to separate values to be able to multiply them together or to factor them out. And that becomes huge later on, is understanding how those numbers work together and why we learn multiplication and division in the first place. So let's look at Bailey. So this is Bailey's birthday party, right? So it's Bailey's birthday party, and she made a favor bag for each of the 5 guests at her birthday party. So I want to draw that out on a little piece of paper. So she's got a favor bag for each of 5 guests at her birthday party, and she put 3 stickers in each bag. And the overall question is, how many stickers were in the bags altogether? First, it's always good to think about how would you solve it, and then maybe how would one of the students you work with or somebody, a student, how would you picture them solving it? So take a second to jot that down. All right. Curious how many people drew out the little bags and then put the 3s on each bag or drew little stickers on the bag. So let me flip back over to our camera here. So sorry, that's a little askew. So this is, again, this is just coming from our text, and I thought it'd be good to kind of reference back to our text. And the way that 3 different students solved this, or the way they went about doing it. So the first being putting some counters into groups of 3. So now we've got these little stacks of counters. We've got 3 of them, and 3 more, and 3 more, and 3 more, and 3 more. So now we've got 5 groups of those 3, and then counting each counter to get up to 15. Think about it. This might be a way to make a multiplication question accessible to a student who doesn't have multiplication skills, right? Whether that kid is very young. This could be a kindergarten, or maybe not a kindergarten, maybe a first grade, a second grade question. But it could also be a 4th or 5th grade question, right? Depending on how we're expecting kids to solve it. A child might also say, okay, I have 3, and then 3 more, and then 3 more, and 3 more, and 3 more. And I'm not picturing those. Notice the difference between 1 and 2. I'm not thinking about those as 1, 2, 3. I'm thinking about them in groups of 3. So I'm thinking group, 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 and that gives me 15. I might be able to do that consecutively, or as they point out, another student might approach that as 3 and 3 is 6, 6 and 3 more makes 9, 9 and 3 more makes 12, 12 and 3 more makes 15. So that's 3 different thought processes, and those are things when we're teaching that it's hard to see when we're doing things with large groups. Hence the power of small group instruction, but not always our best friend. But in terms of logistics, however, there is the difference in being able to put kids together who are using strategy 1 there, and then the 2 different strategies that are related in the second bullet. And then you could also arrange the counters into 5 piles, 3 each one, and just go 3, 6, 9, 12, 15. Each showing a different level of understanding, a different way of solving it. Jump back over here. And let's just think about 2 other, we're not going to look at their solutions per se, but 2 other possibilities here. Mrs. King took 6 boxes of crayons from her desk, and there were 5 crayons in each box. How many crayons were there altogether? Or Molly's bookcase had 8 shelves, and there are 6 books on each shelf. How many books did she have? So when we think about either one of those, thinking about how you would picture it, how a student might picture it, and then the different ways kids might go about solving it. And this is where hopefully somebody is thinking, well, it's just 6 boxes times 5 crayons, so that's 30 crayons. As long as the student is picturing the 6 and the 5, not as 6 times 5 because we're in a multiplication unit, right? But that I'm picturing I've got 6 boxes, and in each box there's 5, and it's a lot quicker just to think of that as 6 groups of 5. Then we know they've got it, right? Or if a student is thinking about that in terms of, well, I know 4 boxes of 6 would be 24, so let me put 5 more, and let me put the other box in there, and then I can get my solution that way. However kids are going to break it up, it's sometimes surprisingly unique between how kids actually picture these things. So getting our kids to draw out what they do, I see that highly common in our classrooms and probably many of yours. Just show me how you're thinking about it. You can have the answer, but show me how you're thinking about that this makes sense to you. As we get kind of towards the end here today, I want us to think about multiple representations. We know we have our 8 standards for mathematical practices. I've adapted this image from our text here, but one thought is to encourage our kids to realize that every multiplication fact has multiple representations. So if this is 4 times 2, there's an array model for that, right? And that array model is going to look like something maybe similar to, see if I can do this with the little pen here, right? So if I'm doing 4 times 2, well, I know I'm going to need 4 rows. 2, 3, sorry, these aren't going to be equal, right? I want 4 groups. My mouse drawing skills are not what they should be, I suppose. If I want 4 groups of 2, well, that might look like that as an array, right? Or it might flip, I could roll that over and show the other one. I could have sets, right? So I could have groups of 2. I could have 4 groups of 2. These are really beautiful. Sorry about that. It's interesting to me when you're working, especially with struggling kids, they will say things like, that is not the same thing as that. And I will say, you are absolutely correct, dear child. It is not the same. But it does have the same value, right? It has the same amount. It doesn't look at all the same. Right? So an area model would be more representative of the size, right? So this would be, if I had the 4, it's going to look similar to an array, right? But it's going to look similar to an array, but be slightly different there. And it could also be repeated addition, right? So this was 4 times 2, so this could be 4 plus 4, or it could be 2 plus 2 plus 2 plus 2. Sorry, those really are pretty bad. My 4s are nice. My 2's not so nice. So to save us on time, we'll go through and draw the area model too, but we could certainly do that where to show what these would look like. I like this model. I never used this exact model, however, I like this because it really forces us to think about what would the 4 things look like. This could be part of a math notebook. It could be part of a classroom multiplication book, something that kids could really value over time. So as we get very close to closing here today, the ideal versus the real. So ideally, we would say, now let's go do a pre-assessment of our kids. Let's talk about which ones are working on which facts and how we're going to work with those different facts over the course of these next few weeks. That might work out for a couple of you, and that would be incredible if it did, because that would be both good for you and it would be great for our group. But in reality, we understand we are in the middle of a year at this point. So, like I said at the beginning, if you can't use these skills, these strategies over the next few weeks with real live children, that's fine. Just practice them yourselves. Give us some thoughtful reflection, and hopefully this is something that's beneficial to you in the long run. So next week, we mentioned earlier, we're going to be looking at multiplying by 2 and 10, so we're really actually going to get into the facts. We're talking about some literature or a book that goes with each one of those facts. We're going to be sharing ideas back and forth. And in terms of homework, all I'm going to ask is when I post this video is that you just write underneath it, I viewed it, and maybe I'll ask you for some sort of reflection at that point. But we'll keep it easy. So thanks for hanging in there with us, and we will see you next week.